Hi everybody, welcome back. Today we're starting a new topic, which is trigonometry and the trigonometric functions. Those are the functions sine, cosine, and tangent. And one of the challenges you're going to face is that it's assumed you have a lot of knowledge of trig functions already coming into this class, and you may have that knowledge, or you may have seen that stuff but have forgotten it, or you may not have it at all. So we're going to start with a little bit of review. And since the trig functions have to do with angles, we're going to begin by talking about angles. This is a review of angles, but I encourage you to follow along just to make sure that you have the basic knowledge that we need. So let's talk about angles. What is an angle? Well, an angle consists of technically two rays, two half lines, but we usually draw them so they look something like this. And when we talk about the angle, we talk about the angle in between the two. And they have a common end point, so there's sort of something about that guy is the angle. Typically, the way that we measure angles, well, here we've measured an angle that goes from, we're going to start on the initial side, and the initial side is always going to go towards the right, the positive x-axis direction, if this was on a coordinate plane. And then the other side is the terminal side. This is the side that we can move to different places to get different angles. And this angle is the angle here. It's an acute angle, and we'll say more about different angles in a moment. But before we proceed, just as a reminder, this is a smaller angle. Of course, we could draw a larger angle. Here, that would be a 90-degree angle. Or we could draw a 180-degree angle. Or if you want, we could think of going all the way around back to the beginning, and that would get us a 360-degree angle. So somehow, first observation is that a full circle all the way around, that is 360 degrees. So I put the 360 here to represent the fact that if we take this side and we move it all the way around until it overlaps this side again, we get 360 degrees. Okay, and then, of course, then we get halfway across the circle if we just draw a line like so. Then we're going to get 180 degrees. Let's go ahead and put that one in. Sorry, that doesn't line up perfectly. Such is life. Here we go. This is 180 degrees. Now, in our day-to-day lives, we're very used to measuring angles using degrees, and we have a sense that a circle is 360 degrees. But in mathematics, in engineering, and in science, we will almost always use a different system for measuring angles. The idea behind it is just the same, which is that we measure the entire distance, that's going to be a number, and then whenever we want to do some portion of that distance, we just divide it up into the appropriate amount of pieces. And for some reason, the number that we use in radians, it is not 360, but instead it's 2 pi. So in radians, 360 degrees is equal to 2 pi, where pi is the familiar number that is related to circles. It's the number 3.1415 ... And there's a very good reason why we use 2 pi, and there's sort of a bad reason why we use 360. And because of those reasons, it makes sense mathematically to use radians and to use 2 pi. We're not going to talk about those today, but that's a question worth asking, which is just why do we care about using radians instead of degrees? Great question. All right, so the main idea here is that if the entire circle all the way around is an angle of 2 pi, or 360 degrees, then half of the circle, well, we know in degrees that's 180 degrees, but it must also, because 180 is half of 360, but it also must be, in radians, half of 2 pi, and half of 2 pi is just pi. So this 180, this is equal to pi. So the angle that goes from here to here, that 180-degree angle, that's equal to pi. Other important ones, well, if we go straight up, then we're going to get an angle of 90 degrees. This is the 90-degree, classic 90-degree angle here. And that 90 degrees, well, it's half of the angle over here. So half of 180 is 90, but in radians, half of pi is pi over 2. Now, of course, we know pi is equal to 3.141, but we could write it as an approximate decimal and divide it by 2. It would be 1 point something, but it just is useful when dealing with angles in radians to always keep the pi in there as its exact value. That is, leave it just as the number pi. So, this 90 degrees is equal to pi over 2. Let me see the angle that is down below. This angle in degrees, well, it requires a little thought here. This is 90, and that's another 90. That gets you out to 180. And then this is another 90 beyond 180, and 180 plus another 90 gets you to 270. So in degrees, this angle is 270. In radians, well, basically, we have a similar kind of argument, except that this is pi over 2, and then if we add another pi over 2, that's another half of a pi. Then we get up to pi. Then we add another pi over 2, and we get 3 pi over 2. So here we get 3 pi over 2. Or 3 halves pi. I like to think of this all as something to do with pi. So this angle is 1 whole pi. This is half a pi, or pi over 2. This is 1.5. The angle from here to here is 1.5 pi's, or 3 halves pi. And then all the way around is 2 pi. That's this one. Okay, so that's the basic setup. And somehow the key fact to remember is that 180 is equal to pi. Now, among the other angles that we need, if I give you the full list of all the angles that you should be familiar with, it looks quite daunting. But all it really does is it's just taking a few different angles here in the first quadrant. Remember, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. It just takes a few angles here and then looks at the corresponding ones if we copy them here, here, and here. And the angles that we have to deal with here, we have 0, same as 2 pi. We have 90, which is pi over 2. And in between that, we want to do two things. We want to divide it in half. That's like a 45-degree angle. That's about what this one is. It's not perfect, but let's just call this one 45 degrees. And what is a 45-degree angle in radians? Well, you have to take that 90-degree angle and divide it by 2. That's like taking pi over 2 and dividing by 2, and that gets you to pi over 4. So let's go ahead and that 45 degrees is pi over 4. And then the other two angles that we want to deal with here in the first quadrant is if you imagine taking this entire angle, 90-degree angle, and dividing it into 3 equal pieces, then what you're going to get is an angle that is 30 degrees and another angle that is 60 degrees. There we go. And our 30 and 60-degree angles, let's put them in first as angles. This one was 30 degrees. This one was 60 degrees. But of course, we can also put them in radians. And in radians, they are exactly pi over 6. And this one, 60 degrees, is pi over 3. Okay, so that gives us, just in the first quadrant, that gives us the initial angle 0. The angle 30 degrees is pi over 6. The angle 45-degree angle, that's a pi over 4. 60-degree angle, that's pi over 3. And then the full 90-degree angle, that's pi over 2. And from now on, I will primarily refer to angles by their radian measurements, although I will occasionally also touch base back into degree measurements. Okay, what are all the angles that we need to know? Well, if we just copy these same angles into the other quadrants, so take this quadrant, divide it in half, that'll give you an angle there, and also take this quadrant, divide it into 3 equal pieces, 1, 2, 3, and that'll give you 1, 2, 3 more angles in the middle here. They correspond to the 3 angles here. Similarly down here and over here, and of course we have to figure out what all those angles are. Let's go ahead and just look at a picture. This appears in your book. What's useful about this is that it has a lot of the information you need about angles in one simple picture. One is the correspondence. Pi in radians is the same as 180 in degrees. Here is the initial side of the angle. This is a positive x-axis. And from the initial side to itself, this is just a 0-degree angle. And this gives it to you in degrees and in radians. And then they have the three angles in the middle that we did. If you divide the first quadrant in half, you get pi over 4. That's a 45-degree angle. And if you divide the first quadrant into 3 equal pieces, 1, 2, 3, then you get this pi over 6 and pi over 3. And there's pi over 2. That's our 90-degree angle. If we go beyond that, for example, if we want to take the second quadrant and divide it exactly in 2, that's like a 45-degree angle, but going up and to the left. And we always think of the angle as starting here on the positive axis, so x-axis. So that goes there. And this angle that we're talking about goes from there to there. It's the angle marked here. You can tell it's bigger than 90-degree angle. And what is it? It's 90 plus another 45. And 90 and 45 is 135. One final note. When we convert between degrees and radians, it can be helpful to note, for example, 135. If we want to convert that into radians, the trick is to multiply degrees by pi over 180. So degrees times pi over 180 will give you radians. And here we have to do some canceling, but it turns out that you can cancel the number 45 out of 135 and 180. So if we cancel a 45 here and here, then it leaves a 3 on the top and a 4 on the bottom, and that gives us 3 pi over 4. Similarly, so this one was from degrees to radians, and then of course the other way is from radians to degrees. If we have an angle in radians, for example, the angle 2 pi over 3, in radians to degrees, what we do to convert is we multiply by just that same fraction but flipped over, 180 on the top over pi. So multiply by 180 over pi to convert radians to degrees. Here, what's nice is that the pi's cancel. 180 cancels with 3. Let me see. 3 goes into 180 60 times. So this cancels here. It'll leave 60. And then 2 times 60 is 120 degrees. And you can see here that 2 pi over 3, that was the angle we started with, is equal to 120 degrees. Okay, this picture shows all the angles that you should be familiar with. They're like the basic angles and then the copies of those angles in all of the other quadrants. So when you see an angle like 270 or 3 pi over 2, it should stir in your mind some idea that this angle is pointing, the terminal side is pointing down. And it should at least be familiar enough that you remember, oh, this is one of the ones I need to know, so let me figure out what it is. All right, that's it for angles.